second problem in the optional exam was to find the volume of the solid generated by revolving the region bounded by the graphs of the equation y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 along the y-axis. So we are using the shell method for this equation, and you would figure out which method works best for you by doing the first two steps written here of sketching the area and then sketching the solid. And then after we sketch the solid, we're going to find the values of the variables. In this case, we're using the shell method, and then we find the upper and lower bounds, and we set up the equation, and then we just solve. So the first step we're going to do is to graph it normally. So since we are not using a graphing calculator, it would be easier to just make a table with the x values and y values. Since it's bounded by x equals 0 and x equals 1, and it's clearly not going to go up to high, just to get a visual, I'm going to do -1, I'm going to do 0, and 1. And we just plug the x into this equation to figure out what the y value is. -1 squared plus 1 is positive 2. And then we plug in 0, which should be 1, and then positive 1 would make 2 as well. So now we're going to just graph the equation. -1, 2, positive 1, 2, and 0, 1. So this is what our graph is going to look like. And then we are going to find where it would be bounded. So since it doesn't go past x equals 1 or x equals 0, the negative values are going to not matter, and the values above 1, x equals 1, is not going to matter as well, which means that it's bounded by this y-axis and 1. So this would be the area that is going to be around the y-axis that's going to make this figure. So we're going to go here, and when it revolves around the y-axis, it is going to reflect around the y-axis. It doesn't have to be to scale. So this is going to be 1. We're going to reflect that. And this is going to be our figure. So to find the variables for step 3, we're going to look at the shell method. And the shell method is the circumference, which this is a circle. So the circumference is 2 pi r for reference. So we're going to sketch it again, a smaller figure, because we integrate because it's cross sections of little solids that add together. And when you're using the shell method, the sides are always parallel to the axis of rotation, which is y. Alright, so this is one of the figures we look at. And since the circumference is 2 pi r, we need to find the radius. So this is the radius of the equation. And when looking closely at this, we see that no matter where the figure would be, like if it was here or here, it's always going to equal the x value, which means that r equals x. So the circumference is 2 pi x. And now we're going to find the height. So the height for this one is right here. And if it's smaller or larger or wherever it is, it's always going to equal y, which is f of x. Which means that our height is going to be x squared plus 1. And then the thickness is just dx, which is why we're integrating. And when we look at the bounds, like I said earlier, when you're looking at the area, you see that it doesn't go past x equals 1. And since we're using x, we're doing this equation in terms of x, the bound is going to be positive 1 and 0. So we set up the equation. 1 to 0. The circumference, which is 2 pi x, times the height, which is f of x, which is x squared plus 1, dx. Alright. Alright, now we just solve. So the 2 pi is a constant, sorry. So we take it out of the integral. So it's just going to be x times x squared plus 1. We're just going to simplify it. So x times x squared is x cubed. X times 1 is x. And now it's just a simple integration problem. So the integration of x cubed is x4 over 4 plus integration of x is just x squared over 2. Bounds are 1, 0, and we cannot forget about the constant that we took out prior to integrating. So we then plug these values in. So if x, we're using 1 first, it would be 1 over 4 plus 1/2. If we put 0 into this equation, 0 over 4 plus 0 over 2 is just 0 times 2 pi. So 1/4 plus 1/2 equals 3 over 4 minus 0 is just 0 times 2 pi. So the answer to this problem would be 3 pi. We multiply back at the constant, so it would be 3 pi over 2.